And we're back live here at the Mobile World Congress in Barcelona. So we're right behind, if you see clearly, the ZTE. ZTE is over there. ZTE over there. And in front of Qualcomm. So we're gonna take a look at some of this stuff over here. And we're gonna walk you through what we see. So ZTE is one of the Chinese vendors for 5G. They have a special area right there, back in that area, where they are demonstrating a lot of stuff to I'm sorry, can I record there? Can I record inside? Only for guests. All right, thank you. It's only for special guests here with a special pass that they can get into the ZTE arena. We're gonna take a look at this demonstration here where they have what it looks like is a waveguide with 5G signaling coming into this. This is a 5G phone, and they are demonstrating the experience of over-the-top chat via 5G simulated in a soft 6 gigahertz band. That means that it's in the 6 gigahertz band, maybe 3.5. Is that a 3.5 gigahertz band?
Yes.
So they're simulating a 3.5 gigahertz. I assume it's all over those conduits right now. And it's somebody's calling, as you can see. And then you have the video chat. So you're chatting with the guy over there? Well. So the first 5G phones, they have another 5G base station here and another demonstration. And these are how the 5G NR and LTE indoor equipment is going to work for in a sub 6 gigahertz band. As you can see here, these are their phones. This is another 10 gigabit Ethernet port connector. These are the screens. We're going to walk you to this area here to check on the phones. The ZTE Axon 9, which is going to be available. Is it available now?
Since September.
Since September. Available since September. And uses Android, 6 gigabyte RAM. 12 megapixel camera is very similar concept as the Samsung Galaxies with the same type of pixel quality for the camera phone. And then we have the V10 Blade, right?
Hi.
Hello.
Can I help you?
Yes, tell us more about this this phone, if you don't mind.
This is the Blade V10.
Okay.
It's a mini-range phone. And the front camera, it has
32 megapixels for the front camera. Wow, that's pretty good.
and it has different options: portrait, selfie, beauty,
Oh, okay.
and it's a very light and soft phone. And in the back we have three cameras,
2 cameras.
16 and 5 megapixels.
Okay.
And the screen has 6.3 inches without frames, is what you're from. And then we have the Blade V10 Vita, that is the light version of the Blade V10.
So it just less pixel selection for the cameras.
Yeah, the front camera has 8 megapixels and the back camera has 13 and 2.
13 and 2.
Both have fingerprint and Face ID.
Okay. Similar to the Apple iPhone
Yeah.
XR. Yeah. Thank you very much. Anna. So Anna explained to us a little bit on what they have here, and now we see here is the IoT narrow. Is it narrowband IoT? NB IoT? Ah, okay. And so we have here the hotspots, their base stations, LTE base stations mostly for what I can see, and different sorts of pet trackers, for example, luggage trackers so you don't lose your luggage. Very useful.
It's for your luggage when you fly in the plane, and the luggage should be located when you leave the plane.
And it's GSM for power.
Yeah, GSM. 2G.
And then we have here some other ones are the elder tracker, kids tracker, and so you have a lot of IoT consumer-driven devices here.
And those are the smart home devices controlled by the GSE.
Very cool. Thank you very much. So as we see, the theme here is control of your home, control of your tracking things, GPS tracking, big displays, big cameras, lots of AR immersion, augmented reality immersion like we saw at the Huawei booth. And we're going to head over to a familiar face, Qualcomm, over there. Qualcomm is a US-based company. Their main thing has been intellectual property and the creation of IP. We have a Qualcomm Snapdragon is one of their biggest chipsets. And they have automotive solutions. They have 5G ARM-based systems here. They have 5G as well. Demo with Ericsson on Hall 2. I'm gonna take a look at Ericsson right after here. The Snapdragon, Qualcomm Snapdragon right here. We see again over here the Qualcomm 5G network. So we see the ultra reliable 5NR. NR stands for new radio for industrial IoT applications. Here Qualcomm booth, the collaborative multi-point, right? So you're doing the COMMP, collaborative multi-point. So you use multiple beams?
Pardon? Yes, you can think of it multiple beams. We're using 16 antennas,
Okay,
creating a pattern. It's not really beam, but it's easier to think of it as beam.
right. And how is that employed right now? What's it? You get 2.1 gigabits?
Yeah, so this, what we're showing here is how you can utilize this in unlicensed spectrum.
Oh, on licensed spectrum.
There is a new unlicensed spectrum, 6 gigahertz, and it's an opportunity to come up with better sharing rules than we have today. And one
Right.
opportunity, if we can time synchronize network, as we're showing here, we can have two networks using the spectrum at the same time.
Okay.
Because the patents for thinking of his beam goes to his own UEs, but he can actually create signals and nothing arrives to the other network's UEs.
So that UE that you have over there, we don't receive the signals from TRP1 and TRP2 only.
Exactly.
And then they will do interference from TRP3 and TRP4.
So this network is listening to the other network's UEs.
Okay.
It's a signal called sounding reference signal. So it picks up that signal and mathematically creates a.
So you tell like look, your power is too high. You're hitting me.
No, it's
Lower
not
it.
Actually, it's through the directionality.
Oh, the directionality of the antennas because you have a MIMO.
Yeah, so it's like MIMO. So these kind of bounces, and they end up when they add up, it's 0 there and 0 there, but it's full power here and full power here. So it creates a pattern like that. So he can transmit full bandwidth.
Got it.
He can transmit full bandwidth, but they're not interfering each other.
So it's just a pattern for the signal strength that you are changing in a way that it will resonate to 0 at UE4
Exactly.
and it will resonate to maximum at UE1. Well,
Yes.
whatever maximum
Yes.
could be. That guy.
And this is a live network running in San Diego right now, and we're using our test devices with 5G modem. So this is real 5G NR going in our warehouse somewhere in San Diego.
That's pretty cool. So are you guys doing anything in the same thing for LTE?
You could.
Yeah, you could, right? Because
this is actually what we're doing. This research to influence what you do in release 16 and 5G. But yes, we could.
because it sounds like you will be able to have better.
Yes, and Wi-Fi as well. So
Or Wi-Fi, right? Yeah.
So this time synchronization we're proposing to be technology neutral, so everybody can do it because it's unlicensed spectrum. So all technology should be able.
Anybody that's in licensed spectrum should be able to use it.
But this is for new unlicensed spectrum. In existing unlicensed spectrum, we have to share with existing rules.
That's pretty cool. I like it. Yeah, I've seen this because like now they do like a lot of like pattern to charge a device, so they like Wi-Fi and things like that. So then kind of be like a similar math, right, that you guys are applying to that. Very interesting. Yeah, you're watching Tech Ed TV here, so you're on Tech Ed TV. Let me give you my business card, so in case you're ever wanted to see yourself on YouTube.
I'm afraid.
And let's see here. Oops. I've been handing out way too many cards.
Where are you based?
We're based out of Boca Raton, Florida. So here's Tech Ed TV. Yeah, so we'll be very happy to see this working pretty soon, I guess, right?
Yes, this is release 16, but to release, this is not a release, this is actually proposing technology that you.
So
It's more of a preview what we can do.
Qualcomm is going to like, oh, say on licensed spectrum is free, but licensed spectrum, that's where we make our money.
Because it's licensed, you have exclusivity, you can get really good performance, so that is absolutely true. But
And then that's where you make money, so that's good.
we are happy wherever they use 5G. The more
Yeah.
the merrier, right?
The more the merrier. And let me ask you this, like who, I was asking something to the guys from Huawei, didn't know, like how is that going to happen with handoff then? Like when do on license to license, license back to on license, then you go to Wi-Fi at home. Is there like a proposal for that? Is something that you guys are working on, or like handovering, like right now I'm in
I
Starbucks.
understand. So there is depends on how everything is going to be deployed. I mean, the feature that operator use unlicensed spectrum for is called LAA, where they actually aggregate license with unlicensed.
Okay.
The beauty of that is you don't have to do handover. You keep the license active all the time, and when you find unlicensed spectrum, you boost the downlink speed. So for LTE, you can provide like gigabit LTE because you can aggregate the licensed spectrum with unlicensed spectrum. And the same is for 5G NR. And this technology we showed here applies to LAA for 5G as well. But this is new proposal.
Yeah, I see it. Yeah.
Release 16.
Yeah, it's more. Yeah, I read that. It's like it doesn't work like that. It's basically what they do is they kind of track the beams and they kind of direct you more beams. So it's basically like a brute force approach, right?
Yeah, we're doing. It may be millimeter wave. You should look at that demo because there we have.
Where is that? Where is that?
It's over here. We're actually showing.
Oh,
we can
okay.
get a really good millimeter wave coverage in enterprise indoor location, and there we have this beam tracking and fast beam switching.
Oh, okay. Let me go and take a look at that one. Thank you. Oh, so you heard that. So they have different ways of doing this. They have a pattern of the RF that is going to be able, and then they have the beam tracking.
The United States. And it's showing how we are testing these different techniques in an indoor environment. I'm going to let him take over because, again, he's the expert. I'm just the marketing guy.
Prototypes. That's video.
That those what beamforming or?
This is being forming. Inspection was a handset with millimeter.
Oh, okay.
So LG got one.
LG has a handset with millimeter wave over there.
That, and there's also Sony and the Samsung device. They also perform. So what we are highlighting here is since very happy
UEs, nodes.
performance list you normally see. So we have our devices, the reference devices. They recommend you to use 3 antenna modules. Right? Each antenna module will have 4 or 8 antenna elements, horizontal, vertical, and normally the
So how do you switch the beams? Like by location or just by signal strength? Or
Mostly single strand, right? In office environment especially, there's a lot of reflection.
right,
Mostly because of glass and whiteboards.
right.
Also in the US especially, even in other countries, there are very strict requirements on the glass in terms of energy efficiency.
So that creates more absorption of the signals or reflection.
It's the opposite.
Reflection.
Reflection that gives rise to a lot of reflection. So especially in the indoor environment, and they put up and also you have multiple antennas on different wires. That will also help in looking at the signals from different angles.
So you basically combine all the signals into one and you have a more powerful output and then... All right, cool. Thank you. So we get to see here how beamforming is being used by, and then we got another robot over there. And apparently that's one of the LG phones. Hello. So this is the LG phone with 5G? So you have a 5G signal right here at 3.6 gigahertz. Sub 6. 28 gigahertz. Nice. So this is the server and this is the client. All wireless. And that's the base station over there. Yeah, Ericsson's. Oh, we don't see it very much. Let's see. Right there, my friends. That's the base station. And this is the CP or phone. Taking care of all this streaming from phone A to phone B. Phone A at 3.6 going over there, and it comes at 28 gigahertz back to this phone. Very cool. Thank you. So this is the new era. So we're going to switch because we're already at 17 minutes, and we need to go to Cisco. And stay tuned. We're watching Tech Ed TV.